Before we begin the tensioning operation, let's get familiar with the tools and safety gear we'll be using today. Equipment display. At the heart of the setup is our ABS multi-stage tensioner, engineered to generate accurate axial load for controlled bolt elongation. Is demonstrated here using a demo flange setup that replicates real-world bolting conditions. To assist with thread engagement,
We will be using clicker wrench.
and to power the tensioner, we've got a hydraulic tensioning pump. It connects to the tool using a hydraulic hose, which ensures smooth and controlled pressure delivery. And of course, safety first. Make sure you're wearing your gloves, safety spectacles, before handling any of this equipment. Once the setup is complete and all safety checks are confirmed, we're ready to proceed with the tensioning operation. Tool feature highlight. Let's take a closer look at the multi-stage tensioner and what makes it so effective. First, notice its compact design. This allows it to fit easily into tight spaces, making it ideal for field operations where accessibility is limited. Next, we have the geared socket, which ensures smooth and controlled rotation of the nut during tensioning. This feature helps maintain accuracy and reduces manual effort. The tool is built for high load capacity, meaning it can handle significant axial forces while maintaining precision. That's essential when working with critical bolted joints. The built-in cycle counter tracks each pressurization cycle, enabling precise monitoring of tool performance and facilitating preventive maintenance. And finally, the multi-cylinder design. This allows the tensioner to distribute force evenly across multiple pistons, improving efficiency and reducing the time required for each operation. These integrated features make the multi-stage tensioner a powerful and trustworthy tool, ensuring unmatched accuracy and consistency in every bolting operation. Mounting the tensioner. To begin, select the appropriate tensioner corresponding to the bolt size. In this demonstration, we'll use the M36 bolt tensioner to match with M36 bolt. Ensure there is a minimum stud protrusion equal to 1 times the bolt diameter, 1 times D, above the nut surface. This clearance is essential for the puller to fully engage the exposed threads and apply proper tension. Next, carefully position the tensioner over the exposed stud, making sure it is properly aligned and seated on the flange surface.
Using clicker wrench.
Rotate the puller until the underside of the tensioner body makes firm contact with the flange face, confirming that the puller has fully engaged the threads. At this point, the tensioner is correctly mounted and ready for the hydraulic pressurization stage. Hose pipe connection and pressure setup. We'll now move on to connecting the high-pressure hydraulic hose, rated for 1,500 bar. Begin by removing the dust protection caps from both the male and female couplers, on the hose and on the hydraulic pump. This ensures clean, contamination-free connections. Connect one end of the hose to the inlet port on the tensioner, and the other end to the outlet port on the hydraulic pump. Before switching on the pump, verify that the dial gauge is filled with glycerin. This minimizes vibration and ensures stable, accurate pressure readings. Also, check that the hydraulic oil in the pump reservoir is filled up to the marked level. This is essential for smooth and safe operation. Next, provide a 230-volt power supply to the pump. Versions with 110 volts and pneumatic operation are also available on demand. Once all connections are secure, activate the pump using the remote control switch. Refer to the tensioning chart to identify the required pressure corresponding to your bolt size and target load. Using the pressure regulator knob on the pump, gradually set the required pressure. Monitor the dial gauge to ensure the system is responding correctly and pressure buildup is steady. Finally, confirm that all hydraulic couplers are firmly tightened and free from leaks before proceeding to the tensioning operation. Always remember, in hydraulic bolting, safety and precision always go hand in hand.
Tensioning operation. Now press the remote control button to apply hydraulic pressure. As the pump activates, the multi-stage tensioner applies axial load, gradually stretching the bolt to the desired elongation. Observe the puller movement carefully. It should rise smoothly and reach the red reference mark. This mark indicates that bolt tensioning has reached maximum piston stroke. Do not increase the pressure beyond this mark, as no elongation can happen beyond this point, and therefore no bolt tension can happen. If necessary, repeat this sequence until the bolt tensioning tool reach the set oil pressure without reaching the maximum piston stroke. Simultaneously monitor the dial gauge indicator to check for the set hydraulic pressure is achieved. Nut rotation. As the tensioner applies axial load, the bolt stretches slightly, creating a small gap between the flange face and the tensioner base. To lock the bolt in its elongated state, we now rotate the nut using the geared socket and ratchet. This action closes the gap and secures the bolt, ensuring the joint remains tight and stable under operational load. The gauge confirms that the tensioning cycle is progressing as expected and the system is functioning correctly. Once the first bolt is correctly tensioned, proceed to the remaining bolts. To maintain uniform load distribution across the flange, always follow the recommended tightening sequence. Display standard bolt tightening pattern. This systematic approach minimizes flange distortion and ensures a consistent leak-free seal. Critical for high-pressure systems and wind turbine foundations, where correct bolt tension prevents vibration and structural risk. Do not exceed the red mark around the puller in order to not exceed piston stroke. Do not exceed the maximum pressure of the tool. Do not stand close to the line of axis of the job when it is under pressure. Depressurizing and removal. Once the nut is locked in the tensioned position, it's time to safely remove the tensioner. Begin by slowly depressurizing the system. Turn the pump regulator knob gradually to release hydraulic pressure. Always monitor the dial gauge to confirm the pressure has fully returned to zero. Disconnect the high-pressure hose from both the tensioner and the pump. Using clicker wrench,
Rotate the puller in reverse to disengage it from the bolt threads. Once fully disengaged, carefully lift and remove the multi-stage tensioner. The bolt is now securely tensioned, and the operation is complete. Advantages of the multi-stage tensioner. Compact design for tight spaces. Its streamlined build makes it ideal for constricted or hard-to-reach areas. Technicians can operate efficiently without compromising performance or safety. Despite its lightweight design, the tool delivers exceptional force, making it perfect for field operations where portability and high performance are essential. You get the power you need without being bulky.